Welcome to my video, Vector Triple Product. This is number 11 in my Vector Math series. So the vector triple product is kind of like a multiplication, well, not really, but you could kind of think of it that way if you wanted to, of three vectors. It's the cross product of three vectors. And so that is a vector because the cross product turns out to be a vector. But the order is important. So this does not follow the associative rule. So it's anti-associative. So in general, we have A cross B cross C does not equal A cross B cross C. So the cross product here, or this vector triple product, is not associative. Now there is one useful relationship. There's actually others, but one that you'll see a lot. And we're going to kind of show this here in a minute, just an example. So A cross B cross C is equal to the B vector times the dot product of A and C minus C times the dot product of A and B. Remember, the dot product will give us a scalar, so it's going to be subtraction of B minus C. So what that tells us is the vector triple product is going to be in the plane of B and C. All right, I'm going to do an example next. So let's define three vectors. A, which is 2i plus 3j minus k. B, the B vector is I minus 4y plus k, and then the C vector is going to be equal to 3i minus 2j plus 2k. So what we want to do is let's find the vector triple product. So A cross B cross C. That's what we're looking for. So first of all, let's just do this B cross C. We can do that. So B cross C, that's just going to be the determinant of I, J, K. That's how we did our cross product. So B is going to be 1 minus 4K, and C is 3 minus 2, 2. What is that? Let's see, that's not a K. What is that? That's a 1. Okay. Now, if we expand this out, cofactor is a minor, so I cross out that first column and row, and we're going to get minus 4, 1, minus 2, 2. Now minus j, and then we're going to delete the second or the middle column, the top row. So we're going to get 1, 1, 3, 2 plus k. And then we're going to get 1 minus 4, 3 minus 2. Expanding this out, we're going to get I times minus 8 minus 2. That's a minus, no, that's going to be a plus 2. Because the minus, and there's a minus, cancels and turn into a plus. Minus j. So it's 1 times 2 is 2 minus 3. And then plus k. And then we've got minus 2. And then we got a plus 12, because we have minus times a minus. So that's going to give us, so now this B cross C is going to be equal to minus 6i plus j plus 10k. Yeah, because we got the minus 6 here, and the 2 minus 3 is 1, and the minus 2 plus 12 is 10. So that checks out. So there is our vector. Now if we want to do A cross B cross C, that's going to be the vector are the determinant I, J, K. In this case, the A vector is 2, 3, minus 1. And then we just did the B cross C, so that's minus 6, 1, 10. Expanding that out, we're going to get I times 3 minus 1 times 10. Let's see, I, we're going to get 3 times, so that's going to be, that's a 1. Okay, there, that's a 10. Let me erase that. 1 and 10. Now we've got a minus j, and then we've got a 2 minus 1 minus 6, 10, plus k, and then we have got a 2, 3 minus 6, 1. Expanding that out, so we're going to get I times 30, and then that's going to be a plus 1 minus j, and cross multiplying it up, that's 20, and it's going to be a minus 6. So 20 minus 6, and then plus k term we've got here, 2 plus 18, so that's a 20. So that's going to give us a 31i minus 14j plus 20k. Yeah, 18 plus 2 is 20. 20 minus 6 is minus 14. 14, and we got a minus. Okay, so there's our answer. That is going to be A cross B cross C. Now let's look at another example. What I want to do is I want to take this relationship that we just saw earlier, where we've got that's equal to B A dot C minus C times A dot B. And I want to show that that's valid for the example we just did, where we've got the vectors A is equal to 2i plus 3j minus k, B is equal to I minus 4j plus k, and C is equal to 3i minus 2j plus 2k. Okay, we just calculated this in the first example, so we know that side. So now we need to calculate this side and show that they're equal. So first of all, let's do A dot C. Now if you remember from the dot product, it's just going to be, you multiply the individual components together. So for AC, it's going to be 2 times 3, that's the I components, plus 3 times minus 2, and then that is going to be a plus, and let's see, we've got a minus 1 times 2, minus 1 times 2, which is going to give us, that's a 6, that's a minus 6, and that's a minus 2, so that's a minus 2. So that's going to be A dot C. Now we need to do A dot B. And that is going to be, in this case, we've got A is 2 and B is 1 in the I components, plus, and then we have got a 3 times minus 4, and then we've got a minus 1 times 1. So that's going to give us 2 minus 12 minus 1. That's minus 11. So that is going to be A dot B. So now if we expand this out, we're finished this side here, so it's B times A dot C minus C times A dot B. Just writing that out, we're going to get, since B is going to be We've got the minus 2 in front of it because that's the A dot C. Now let's just reproduce B again. It is I minus 4J plus K. Now we have got, and we're subtracting these, but the A times B, in other words, this term right there, is minus 11. And then we multiply it by the vector C, which is 3I minus 2J plus 2K. Now we just need to do the math on this. So this is going to turn out to be the 2I plus 8J. And then it's going to be minus 2K. And then this term's right here, so that's going to be a minus, that's going to be a plus 33I minus, and that's going to be a plus, so that's minus 22J plus 22K. Combining like terms, the i's go together, and so we've got, let's see, the 2, that is a minus 2 there. And so we get 31I minus 14J, because we've got minus 22 plus 8 is minus 14. And then we have got minus 2 plus 22 is a plus 20K. And if we go back to our first example, that is the same answer that we've got. Cross multiplying those, so that does check in one case. So that's equal to A cross B cross C. So that we did validate that one example. All right, well, I hope you got something out of this and learned a little bit more about vectors and the vector triple product. And thank you for watching, and don't forget to leave some comments if you got some questions. Thank you. Bye.